Hey, welcome everybody to lesson 3.1, learning about energy release in the body. We're going to start learning more about just what the process is that the body goes through to actually make this energy. What is happening inside of those cells? We know that something is. We know that it's requiring some molecules. And today, one of the things we're going to try to do is pinpoint which of those molecules, even though we've already kind of talked about it a little bit. So first things first, warm up. Here we go. Come on. There we go. Warm up. And we got a little poll here. I'm going to go ahead and jump into it in Amplify. Now, if you did not already do lesson 2.7, spoiler alert, we're going to tell you what Elise's condition is right here. So here we go. In chapter 2, you received Elise's test results, and you compared those results to your sim test results for a healthy body. The data table shows Elise's test results and test results from a healthy body. Use the data to answer the questions below. So I told you there was going to be a spoiler alert. I guess it's coming. Sorry. I jumped the gun a little bit there. We have our test results from the healthy body and then from Elise's body. So answer these questions right here. Compared to the cells in a healthy body, Elise's cells are getting far fewer what molecules? Now, if we look at this, some of you might want to immediately say, well, they're getting far fewer oxygen molecules. Look at that, 30 less oxygen molecules? That seems like a lot. Well, when you consider the total of 300 for a healthy body, that's really only 10%. Difference in oxygen. Amino acids, healthy body, 37. Well, Elise is getting way more amino acids. Could that be a problem? Well, it doesn't seem to be. But for glucose, Elise is getting less than half the same amount of glucose a normal healthy body is receiving her cells. So we would, I'm giving it away right now. We would put glucose here. Well, okay, how do you think getting fewer of these molecules to her cells contributed to Elise's tiredness? Explain your ideas. So here's what I really want you to do. I want you to think through this and try to explain, all right, so she's getting less glucose. How does that contribute to Elisa getting more tired? Go ahead, answer that question and come on back to me. All right, why do glucose molecules, why would that lead to being tired? Well, today, activity 2, considering claims about energy release. Here's the spoiler I was talking about. If you haven't already figured it out, Elisa was feeling extremely tired. Why? Well, based on the analysis you did, we now know that she has diabetes, a condition that can prevent glucose from entering the cells in her body. So Elisa's cells are not getting enough glucose. And for those of you that read about diabetes and studied a little bit about diabetes, we know that it could be that her body is not producing enough insulin, which is not allowing the glucose to enter her cells in the first place. So her cells are basically being starved of glucose. Let's move to our chapter 3 question. How do molecules in the cells of the body release energy? We've been talking a lot about this energy that is occurring. We even saw some energy. We pointed it out in the simulation when we saw certain molecules coming together in the cells and energy being created. Well, what is actually going on and how do molecules in the cells of the body actually do that? So our investigation question today is which are the molecules that the body needs in order to release this energy? So in activity, which activity is this? I think 2. You are going to just pick. What do you think? We've looked at 3 main molecules. We've looked at glucose, amino acids, and oxygen. Which of those molecules or which combination of those molecules do you think cells need in order to release energy? You're going to go ahead and you're going to answer that in number 2, activity 2 on Amplify, right down here. Okay, so go ahead, think about that question, look at those responses, and choose one, and then come back to me. What'd you say? Which molecules? Well, I think it's the propane. No, I don't know. Hey, activity 3, we get up and we get to move around. So this will be fun. We're going to gather evidence from our very own heart and breathing rates. And we got a little activity where we're going to try to increase our heart rate and our breathing rate. We'll be gathering evidence today to help figure out which claim is best supported. We'll start by observing what happens in our bodies when we increase our level of activity by running in place. Since movement requires energy, we can see what happens to the body when it uses more energy. It's really fun to do this in the classroom because there's not a whole lot of room and everybody is just running in place as fast as they can. Some people go a little bit crazy. You will observe your heart rate and breath rate before and after you run in place. Why before? Oh yeah, we need like a baseline, right? So this is one of the questions that we are going to be looking at. What could changes to your heart rate and breath rate tell you about what is going on inside your body? Think about that question right now. Let's say that you run in place a lot and your heart rate slows down. What does that tell you? Let's say that it speeds up. What does that tell you? Let's say it doesn't change at all. What does that tell you? Same thing with breath rate. If it goes up, if it decreases, if it stays the same, what does that tell you about what's going on inside your body after you run in place? Well, here's what we're going to do. We're going to observe our heart and breath rate before we run, and then we're going to exercise vigorously for 1 minute, okay? You can run in place. You can do something else as long as it is some vigorous exercise, okay, for 1 full minute. And then as soon as you stop, you want to measure your heart rate again and your breath rate again. And then think about, okay, well, what happened? What did you notice? What were your observations? It says discuss with a partner. I realize you don't have a partner. You could email somebody, call up somebody and say, hey, what happened to you? Well, let me tell you what happened to me. But you're going to make some observations about that. Now, let's talk about finding your heart rate, because sometimes that can be kind of hard. So here's some steps to try to find it by putting 2 fingers. Where does it say? Gently on your neck, just under your jaw. If you've done this before and you found what's called like your pulse, then maybe you're already really familiar with that. You can do it on your wrist. Sometimes you can even see your heart beating. If you've got a sweet fitness tracker device, you can use that. It'll tell you your heart rate. There are apps for your phone. Instant Heart Rate, I think, is one where, there's like ads and stuff that pop up. But there's all sorts of stuff. Actually use the flash, the light on your phone, and it can record your heart rate that way. It's pretty cool. But anyways, there's a lot of ways to do it. But this can kind of be tricky for some students, all right? So may I say this, if you have any kind of condition where it might be dangerous for you to increase your heart rate, increase your breath rate, to do any kind of vigorous physical activity, then please don't do this. And you can let me know that this is not something you're going to be able to do, and I will figure out something else that we can do. I'll help you get some data some other way, okay? So without further ado, go ahead, measure your heart and breathing rate now, make a note of it, do vigorous activity for a minute, and then measure your heart and breath rate again, and come back to me. Are you huffing and puffing? Did you blow your brother or sister down? I don't know. Hey, what did you notice? What happened to your breath rate? Did it increase or decrease? I think most of us probably would observe that our breathing rate increased. So, which molecule, think of this question now, is taken into the body from the air that we breathe? If you're breathing more and more, why do we breathe in the first place? What is that molecule that we're trying to bring in? Why do you think the respiratory took in more of that molecule while you were running? What are we doing? We're using more energy and we're breathing heavier. What molecule are we taking when we're breathing? Oh yeah, oxygen. So there's something about that oxygen and making energy and using energy. There's a connection there. Next thing, what about your heart rate? Most of us probably noticed that our heart rate went up. What does the increased heart rate tell us about the circulatory system? What does the circulatory system do? What does it bring around to the body? Why do you think the circulatory system was pumping blood faster than when you were running? Now, breathing, it's pretty, obvious. Okay, oxygen, breathing, right? But circulatory system, we know that there's a lot of things going on with the circulatory system. Maybe the circulatory system was just bringing that oxygen to all the different parts of the body. Maybe it was bringing something else too. I don't know. We're going to jump into the sim and we're going to try to get to the bottom of this. So we're going to use the metabolism simulation to get more evidence about the relationship between energy and the molecules that are getting to the cells. You're going to conduct, count them, 3 tests. That's 6, Mr. Wiggin. Oh yeah, 3. In the sim to determine which molecules are needed in the cells for energy release. In each test, you will eliminate 1 molecule, just 1 each test, either glucose, oxygen, or amino acid molecules, and then see how that affects the body's ability to release energy. Tricky how we're going to do this. When you go into Amplify, notice that the first data, the row in the data table, is filled in for you. So we're in activity 4 here, and the data table is already filled in. So this is our control test. This is the one that we're like, everything's just normal. We didn't deprive the body of any of its nutrients that it needs. And what are we doing? We're looking at how long a person can jog before they have to start walking. That's what we're looking for. So with this first test here, what we're seeing is if this person was breathing, if they ate one fish and if they ate one corn, because I always eat my meals by units like that. Can I have one fish and one corn for lunch? Thank you. How long can they jog for? Well, for trial number 1, looked like 100 to 132 time units. What are time units? Seconds, minutes? It's ambiguous on purpose. Trial 2, same thing, 100 to 132 time units that it took for this person to finally get tired and have to start walking. We're basically going to do this test again, but now we're going to deprive this person of glucose. Then we're going to deprive them of amino acids, and then we're going to deprive them of oxygen. And we're going to see, how does this number change? Does it go up? Does it go down? Does it stay the same? And then, of course, we're going to discuss, what does that tell us? So let's look at actually the directions really quick, because it's important to do it right. Let's see, not enough energy. Yeah, okay. So let me walk through these with you, because a lot of people are going to look at all that and they're going to say, okay, skip. Don't skip. We always want to read the directions. So for each test, launch the metabolism simulation. Select healthy body and select observe. Well, I have it up right here for us. Healthy body, boom. Yes, reload, observe. But then it says the next thing was pause it. Make sure you pause it right away. So I hit pause on mine. Good. Pause the sim and set the activity level to jog. Okay, activity level. Oh, look, here it is. Activity level, jog. Now what do? Well, let's go back to the directions. Let's find out. For the without oxygen test, also press stop for the breath. Well, which one am I doing first? It looks like I'm doing test A, without glucose. Okay, so breath is on for that. But where would I find that? Where? Oh, breath. Here we go. I could click that and say stop. No, don't stop. Okay. We're leaving the breath on for this one. Press play and then feed the body as directed in the data table for that condition. Okay, so without glucose, breath is on. I'm going to give this person one fish. I can't actually preload that because I'm not in the test. So immediately switch to graph view and wait for the activity level to drop from jog to walk. Pause this and record the length of time the body stayed at jog. Hey, can we just do this together? It'll be easy. So I'm going to bump up my speed, actually, because I love bumping up the speed. I'm going to hit play. I'm going to feed a fish and then go to the graph view. Fish, play. Eat a fish. Graph view. Right. Let's see. Activity level, jog. Jog. You're jogging. They're jogging. They're jogging. They are still jogging. Look at all these units of time. Oh, look at that. Boom. They went from jogging, see, activity level is that purple line there, from jogging. In fact, we can go ahead and even just get rid of all of those so it's easy to see. From jogging to walking, it looks like it happened at 81 units of time. That's what I would put in my data table. 81 time units, okay? Do you have to put time units? Sure, why not? You always want to include your units. And then do it again. See if you get the same thing, okay? Follow the feeding program with for each of the tests. Follow the breathing program for each of the tests. Make sure you have it set up correctly. And make sure you reset it every single time. This reset button right here, reset, start over. Yeah, I want to start over. And I just want to observe. Make sure you hit pause right away. And then do your test, okay? Run those tests, collect your data, and then come back to me. Awesome. We have our results. We have our data. We've collected it. Now let's revise our claim. We collected evidence from two sources, from our own body when we ran in place and from the sim. Now we'll return to the claims, discuss which claim you think our new evidence best supports. Now, we made a claim at the very beginning. We said the body needs these 2 molecules or 3 molecules or just 1 molecule in order to make energy. If you've decided at this point, hey, you know what, I was wrong, that's fine. In fact, that's what you want to do. If you know you're wrong, you want to admit it, not just keep going ahead with that wrong answer, trying to prove it somehow. No, let the data guide you, and let it guide you to the correct answer. So if you see that the data is leading you somewhere else, then maybe that's where you should head. I'm not saying just give up on your previous claim altogether, but consider like, hey, maybe this previous claim is incorrect. So it's okay if you've changed your mind. Scientists regularly revise their claims when they get new evidence. So that's what you're going to do in activity 5 here on Amplify. It's very much like the warm-up. You're going to click which one do you think, which of these molecules you need, and then how does the evidence support the claim? What is the evidence? The evidence is your breathing test when you did the activity, the breathing and heart rate test, and the evidence is the data that we just collected in the sim. So go ahead and answer that and then come back to me. Well, we're supposed to discuss this. Which molecules do cells need to release energy? Explain how the evidence supports the claim. Spoiler alert again. Gosh, just full of them. Here it is. In order to release energy, cells need both glucose and oxygen molecules. Our tests pointed us to this, that we realized if we turn off the breath, someone's not going to be able to jog for very long at all. Also, when we engage in vigorous activity, our breathing rate goes up. That means we need that oxygen. In the test, we also noticed that when a person was getting more glucose from their food, they were able to jog longer. If we deprived them of that glucose, they were not able to jog as long. So Elisa, she had low levels of glucose molecules in her cells due to the condition of diabetes. The evidence you gathered reveals why low glucose levels contributed to her extreme tiredness. We know she had low glucose. Now we realize, okay, glucose actually is needed in the production of energy. Fun stuff ahead. We're going to continue to learn more about how energy is released in cells in the next lesson. Not just what molecules you need, but what is the actual process. Hey, homework time. For the homework, we're going back to the simulation. We are collecting more data. The simulation has provided us with such useful information. For this activity, you will run additional sim tests to compare 2 different activity levels, running and or jogging and resting in a healthy body. Then you'll record the results in the data table. Let's look at what those directions actually are. Here we go. Select healthy body, then select test. Okay, let's actually take a look at what that looks like. Healthy body. Let's reset. Yes, start over. Ooh, test. Here we go. Now this is where you can actually select which food I'm going to feed this poor soul. So it says select how many corn? 6 corn. Do 2 trials for each activity, rest and jog. So you do have to change the activity level. One of them is going to be rest, or 2 of them are going to be rest, and 2 of them you're going to set it to jog. You are going to run the simulation, and then you're going to record the glucose molecules absorbed by the cell, oxygen molecules absorbed by the cell, and then any other observations you have. Where do I find glucose and oxygen molecules absorbed? You find that in the graph view. It is going to tell you right here, okay? And that's where you'll find that data. So, hey, do those tests in the sim. Congratulations. We now know that glucose and oxygen are needed in order to produce energy in the cell. We'll see you next time.